All right, folks. So here we are, day 3 of the COVID-19 shutdown. It looks like we'll be shifting to doing some things online. So I'll provide some video instruction. I'll provide the notes. I'll provide some online quizzes and opportunities for you to keep up on your learning of AP and preparing for that AP exam, which as of now, the College Board is planning status quo, meaning things are looking like they're planning on testing in May. All of that is up in the air, and so I'll try to keep you posted on what they are saying. I suspect it'll be pushed back, but we'll see. So that you are prepared, as prepared as possible, I will go over these problems and then post various activities that you can do online, probably through Google Forms and things of that nature. So anyway, I'm looking at page 7 of the Unit 10 Buffers and Titrations packet that we were working on, and frankly just about finished before all of this happened. So anyway, these are certain reactions that may pop up as are related to buffers, titrations, acids, bases, and salts. So one thing I want to say before I start doing these various problems is I am coming up with net ionic equations in each of these. But the goal is not net ionic equation writing. The goal here is to look at how equilibrium is affected by acid-base chemistry. So for instance, this particular problem says that hydrochloric acid is being added to solid magnesium hydroxide. And so again, I'm going to come up with a net ionic equation here, but that is not the goal. The goal is to look at how does an acid added to this solid affect the shifting of its equilibrium. So this is solid magnesium hydroxide. And so there's the chemical formula of magnesium hydroxide. Now, as the hydrochloric acid solution is added onto it, some of this magnesium hydroxide, which is a slightly soluble. Now, here's where things do get a little bit confusing. I know this is considered a strong base, but even though it's a strong base, it's only slightly soluble. The long and short of it is, don't worry about all those miscellaneous details. I'm not going to try to trick you, and neither are the AP folks. So it'll ionize into magnesium and hydroxide ions. So the second reaction that will occur is the addition of this hydrochloric acid. Now, hydrochloric acid being a strong acid, I'm just going to ionize it into the hydrogen ion, which the chloride ion will end up being a spectator ion, so I'm going to ignore it. The hydrogen ions are going to react with these hydroxides. So it's going to need 2 hydrogen ions to react with 2 hydroxide ions. So I'm just bringing those hydroxides on down here. And so we get 2 hydrogen ions reacting with 2 hydroxide ions. Now the K of that reaction, remember, this particular reaction, maybe I'll remind you, these are things I would be peppering you with questions about. Remember, this reaction here has a K value that we call the KW of 10 to the negative 14. So notice essentially what I'm doing is writing the reverse of this, where the hydrogens are going to react with the hydroxides to produce water. Well, being that these are producing water from hydrogen and hydroxide, 2 waters I mean, notice that this is the reverse. And so notice this K value of this reaction would be 10 to the positive 14, meaning very, very large. It's a completion reaction. It is not a equilibrium reaction in reality. So the K of the reaction up here, I honestly don't know, nor do I care, but it's about the solubility of magnesium hydroxide, and it is a low value. It's less than 1. And so remember, when we multiply, when we add 2 equilibrium reactions together, we multiply the K values. Well, this K value is, again, to reiterate, huge. So it is going to overwhelm the K value here. The net of what I'm getting at is the K value of reaction number 3 is going to be way, way greater than 1. In other words, a completion. And so now if we add these 2 reactions together, the 2 hydroxides cancel out. And what that leaves us with is magnesium hydroxide solid, reacting with two hydrogen ions, and it produces magnesium ion and two waters. And notice I just ignored the chloride because it's going to be a spectator ion, so I can either ignore it now or later, and that'll make life much easier. Now again, what I was pointing out was we'll end up with a net ionic equation, and that's all wonderful. And quite frankly, if you were just asked to write the net ionic equation for this, I would not have gone through all of this. I would have just jumped right to writing magnesium hydroxide plus hydrogen ions makes magnesium ions and hydroxide ions. Excuse me, I just misspoke. It doesn't make hydroxide ions, my bad. It makes two waters. There we go, that makes a lot better sense. So the point of this is, notice how the hydrogen ions removed the hydroxide ions from reaction number 1, causing this system in number 1 to shift to the right. In other words, if you add hydrogen ions from acid, in this case hydrochloric, you will cause a shift to the right. Now remember, in a formal setting like on the AP exam, I wouldn't be saying shift right, I'd be saying proceed toward the products. But anyway, it's going to shift to the right. And what we're talking about by shifting to the right is it increases the solubility. It makes that magnesium hydroxide dissolve better. So I'm going to hit stop here. I guess I should answer this question. So how does the second reaction affect the hydroxide concentration? In which direction does the reaction shift? So I believe we've added this shifting. It shifts to the right. And then the second reaction, what it is doing is grabbing onto and reacting those hydroxides. So ultimately what it's doing is decreasing the hydroxide ion concentration. So it shifts right. Instantaneously, the hydroxide ion concentration goes up, but then the hydrogen ions grab onto those hydroxides and remove them from the system, thereby creating this shift right. So I'll hit stop before I move on to example number 2 so that you can process that. And there are various homework problems in the packet, as you know. I'll let you go back to those and start practicing a few that are similar to this before I just do a couple of others. And then I'll post the answer key and things like that so that we'll progress kind of as normal as is possible. See you in a minute.